the standards of length and mass and time. We will study the first article is standard of length, mass and time. These three things are important for us. But before studying this one, first I will define the physical quantity definition. Physical quantity. Physical quantity mean what? Physical quantity mean the quantity which we can measure with some apparatus, with some machine. That is called physical quantity. And if I write the physical quantity with PQ, and this is equal to what? This is equal to two things. One is the value, numerical value. Numerical value mean the numbers. The numbers 1, 2, 3, 4, 5, 100, 100, 2000, like this one. This is the numerical value. I am writing here numerical value and the unit. So if I write here 10 meter, it means the numerical value is 10 and meter is the unit. If I change the unit like this one, kilogram, then its sense will be different. So 10 meter mean what? 10 meter mean it is the length, it is a distance. But 10 kilogram mean what? It is the mass. If I write here 10 second, then it means it is the time. So any physical quantity mean which we can measure. If you change the unit, its quantity will be changed. So the quantity totally depends on the units. If we are saying that we have 100, 100 mean what? Nothing. 100 mean nothing. So when we put here meter, then it makes sense. When we put here kilogram, it makes sense. When we put here second, then it makes sense. So remember, any physical quantity has numerical value and unit. So any physical quantity, and all physical quantity exist in physics and are in science. So normally we are discussing three types of physical quantities. One is called fundamental quantity. So in fundamental quantities, there are 7 fundamental quantities in physics or science. One is length, one is mass, one is time. For our syllabus, we will focus only these three, but another's are temperature, another is current, another is intensity, and the last is amount of substance. So these are called the fundamental quantities. We will focus only on 3 quantities: length, mass, and time. So if we want to write the units, its fundamental unit is meter. Its fundamental unit is kilogram. Its fundamental unit is second, not hour. Its fundamental unit is Kelvin, not Celsius, degree Celsius. Ampere. And this intensity is actually the intensity of the radiations, and this intensity is related with some energy of the radiation. But we are not discussing here anymore, but you should remember this one, that this is called luminous intensity and its unit is candela.
وين له؟ تحضيري مو هنا بعيد شوي.
احط ميوت
بس
Okay, please
هناك اتوقع
please quiet.
مدخل كذا. استنى خلينا اشوف لك.
Okay, please quiet, because In this way, you cannot understand. So the amount of substance is measured in mole. This is in chemistry. Mostly in chemistry, we are using mole. But we are discussing here length, mass, and time. Okay, see here. Meter is the fundamental. But you can measure in centimeter. You can measure in millimeter. You can measure in micrometer. Kilogram, you can measure it in gram. You can measure in microgram, milligram, like this one. Second, you can measure in hours, minutes, and seconds. Okay. So this is our fundamental quantities, and this is our fundamental units. And this is called fundamental quantity one. First is the fundamental quantity. And the second is the derived quantities. Derived mean what? Derived mean which is totally based on fundamental. So if I want to write the speed unit is meter per second. Acceleration unit is meter per second square. So speed and accelerations are derived quantities, and their units will be derived because meter per second. It is a combination of meter and second. Then it is called derived. Okay. So understand this one. Length, mass, time, and derived quantities are derived units. So we are using frequently derived units and quantities in physics in this chapter or in this syllabus. Okay. After this, we have some other quantities, and that is called supplementary quantities. Supplementary. These supplementary quantities have two. One is angle and the other is solid angle. This is just for your information. You should not focus on this one. Angle, you know that you measure in degree, but normally we measure in radians. If you see in the calculator, there are some options, convert degree and radians. So we will study angle in this syllabus, but we will not study the solid angle. Solid angle is actually three-dimensional. And three-dimensional mean if you have a cone like this one and you want to measure this angle, then this angle will be solid angle. This is called solid angle. This is area of this side and this is the radius. So I'm not going in this direction. So we will focus only on degree and radian in this syllabus. So the quantities have three types: fundamental, derived, and supplementary. But we are focusing on fundamental and derived. And in which fundamental quantities we are focusing? We are focusing only length, mass, and time. Only three quantities. These fundamental quantities we will focus. Okay. So if you see your book, he has defined the length, he has defined the mass, he has defined the time. So length before 1960, it was defined by the meter rod, and this rod is made up of platinum plus radium, and it is kept in Paris, but it is kept in 0 degrees Celsius. So when you have changed the temperature, the length is changing. So that's why they delete this definition and then they found a new definition. And in new definition, what they said that the distance traveled by a light in vacuum. So they measure this 1 meter length with the light, distance traveling the light. So they change the length of the definition and putting new definition. Okay. After this, mass, This mass is a cylinder mass is taken, and this cylinder is also alloy of platinum plus radium, and it is also kept in Paris, and we are taking 1 kilogram from that standards. And time is also before 1960, the time definition was different, because it is defined with the mean solar day, and the rotation of the earth is changing during the time. So they changed this one, and then now we have a new definition of time, and new definition of time is related with the cesium clock, cesium atomic clock. Okay, you can see and check in your chapter number 1. Okay. So this is all about the fundamental and the derived quantities. So now we are going towards the numbers. Numbers are very important in science. See, how to write or methods of writing numbers. Methods of writing numbers. Numbers. So one is ordinary form. Ordinary form. One is scientific form. Scientific form. And the third one is prefix form. Prefix form. Okay. Ordinary form mean what? If I'm writing 1000 meter, this is ordinary form. If I want to write this number 10 raised power 3 meter, this is scientific form. If I want to write this number in kilometer, this is prefix form. So we know that 1 kilometer is equal to 1000 meter. And you can write this one 10 raised power 3 meter. All have the same value. The values are same, but their style is different. This is this style. This is this style. This is this style. Value is same. Okay. So we are focusing on prefix form. So prefixes are fixed. What are those fixation? See, milli, we are saying milli. So milli mean 10 raised power minus 3. Micro. Micro mean 10 raised power minus 6. Nano. Nano mean 10 raised power minus 9. Pico. 10 raised power minus 12. Femto. This is femto. Mean 10 raised power minus 15. Like this one. So these are the small values. But bigger than same 10 raised power 3. 10 raised power 6. 10 raised power 9. 10 raised power 12. And 10 raised power 15. So this is called kilo. This is called mega. This is called giga. This is called terabyte. This is, I don't know. You can see and check in your book. Okay. So kilo, mega, giga, tera. So all these things are called prefixes. Prefixes. If we have some number, we can convert it into other forms. Suppose we have 1 millimeter. 1 millimeter. We can write it 10 raised power minus 3 meter. We can write it 1 over 1000 meter. We can write it 0.001 meter, like this one. Okay. So writing the numbers in different styles is very important. So when you will go in the labs, you will do the experiment and you will see some numbers are very small and some numbers are very large. The large number is, to control the large number is easy, but to control small number is difficult. Okay. After this, so here you can see, I have just discussed with you the units. About the units. Units are what? Length unit is what? Length unit is meter, kilometer. centimeter, millimeter. But it is length. Length is length. Either is in meter or it is in millimeter or is in micrometer. Length is length. Okay. Then mass. Mass you can measure in kilogram, gram, microgram, nanogram. Maybe nanogram is very difficult. Microgram. Okay. So time. Time you can measure in hours. You can measure in minutes. You can measure in seconds. You can measure in microsecond, millisecond, nanosecond, femtosecond. Up to femtosecond is available. Okay. But time is time. Now I'm giving you the concept, the further concept before, after units. That concept is called dimension. Dimension mean what? Dimension mean you can write, instead of all this one, you can write L. L mean the length. Either it is millimeter or centimeter or micrometer. Length is length. Mass is M. Time is T. So if we combine length, mass, T in bracket form, then we call it dimension. Okay, I'm giving you the examples, then you can understand more. Here, maybe you cannot understand. So area is what? Length into width. This is area. This is the definition of area. Okay, length is measured in meter. Width is measured in meter. Meter mean length. Meter mean length. So L into L mean L square. So what is the dimension of area? L square. If I am writing volume, so volume is what? Length into width into height. So length is meter, width is meter, height is meter. So length into length into length. So this is L cube. So dimension of volume is L cube. Now I'm writing some more examples. Suppose I'm writing here speed. Speed unit is what? Meter per second. Meter is what? Length. Second is what? Time. So you can write LT minus 1. This is the dimension of speed. Acceleration. So acceleration is what? Meter per second square. So meter is length and second square mean T square. So you can write LT minus 2 like this one. Similarly, if we have more example I am taking, F is equal to MA. This is the famous equation which you have studied in your previous class. Okay. Mass, kilogram. A, meter per second square. So kilogram mean what? Mass. Mass. Meter mean length. Second square mean T square. So you can write MLT raised to power minus 2. So this is the dimension of the force. So any quantity whose units you know very well, you can make its dimension. If you know the units, you can make the dimension. Okay. So similarly, work. Work unit is what? Joule. Joule is equal to Newton into meter. This is the definition of joule. You will study. So Newton, here you can see the Newton dimension is this one, because force unit is what? Newton. And Newton you can expand like this one. And here Newton dimension is what? MLT minus 2. MLT minus 2. Multiply meter. Meter mean L. So the dimension will become ML square T raised to power minus 2. So this is the dimension of work. And this is the dimension of force. One thing. The second thing, which is very important, that if we have this equation, x is equal to VIT plus half AT square. You have studied this equation at high school physics. Here x is the distance. Okay. and distance is length, is measured in length, and length dimension is L. So it means its dimension is length. What will be the dimension of this one? What will be the dimension of this one? Leave this 1/2. So its dimension will be L. Its dimension will be L. Otherwise, this equation is wrong. Now, if you can find the dimension of VIT. Well, VIT mean what? You can write meter per second into second. So what is the answer? Meter. It means L. AT square. AT square mean A mean M meter per second square into second square. So second square cancel. Answer is what? Meter. So meter mean L. So any equation whose each term dimension will be same, otherwise that equation is wrong. So remember this important concept about this dimension. Okay, so you can suppose if we have this equation 1/2 AT square. So if you want to find the dimension, what will be the dimension? Leave this one 1/2 A meter per second square into second square. This is cancel. Answer is meter. Meter mean L. So the dimension of X will be L. L mean it is distance. It is length. Okay, one thing. The next thing is the conversion of the units. Conversion of units. Conversion of units. How you can convert the units? So you know that 1 kilometer is equal to 1000 meter. You should remember this one. Okay. And 1 meter will be how many kilometers? 1/1000 kilometer. Okay. And one more conversion is frequently used in this syllabus. That is kilometer per hour to meter per second. So what you will do? If we have this value 72 kilometer per hour, we want to convert it into meter per second. What we will do? 72 into 1000 divided by, in 1 hour, how many seconds? 60 into 60. So you can solve it and get the answer. The simplest way is this one. If you want to convert kilometer per hour to meter per second, you have to multiply this factor. And if I simplified this factor, I can simplify like this one. Okay, so answer will be 10/36. So more simplification is 5/18. So if you multiply any number with 5/18, you will get meter per second. So the concept is this one, that kilometer per hour to meter per second, you have to multiply 5/18. If you want to go meter per second to kilometer per hour, you have to multiply 18/5. So remember this factor. Just remember. Then you can do this job. Yes, student. If you have any question, you can ask me.
All clear.
Because yes.
I kind of missed it. Why is 5/18 used to convert?
Yes.
Why that number?
Because kilometer mean what? 1000 meter.
Yeah.
And hours mean 3600 second. 60 into 60. Okay. So if you simplify this one, these two will cancel with this one. Okay. So this is 10/36. So 10/36 mean what? 5/80. So that's why I write here 5/80.
Okay. Thank you.
So the first chapter is very simple and easy, I think, but some students cannot understand the concept of the dimension. I just give you the one equation. I'm writing the one equation and you understand in more good way. The equation is x is equal to, suppose, at cube plus bt square plus ct. Okay. The question is the dimension of the constant b. What is the dimension of this one? Find the dimension of b. Find the dimension of a. Find the dimension of c. We know that the dimension of x is L. So to make it L, what we have to do?
All other variables must be L2.
Yes, all of the variable must be L. It should be L. It should be L. It should be L. Okay. So to make it L, this is at cube. So what will be the answer? So what is the answer of this one? It will be
L cubic.
L over T cube.
Cubic,
Okay.
yeah.
And this is T cube. So this will cancel. Answer will be L. What will be the B? So B will be
Acceleration.
L over T square for B. For C, it will be L over T. Understand?
Velocity.
Okay, understand this one. When you write like this one, answer will be L. When you write like this one, answer will be L. So our target is to make it length because our left hand side is length. So all terms, each term must be length. How to make length? We have to decide A, we have to decide B, we have to decide C according to this one. Okay. Understand?
Understand.
Yes, any question? Okay, let's see another example. This is the last question. The question is x is equal to 1 over 2 at square plus bt cube. The question is the dimensions of A and B. So these are the questions which already come in the previous exam. You can see. So remember 1 over 2 is constant. It has no dimension. Leave this one. So you just focus on at square. You just focus on bt cube. Okay. Other is nothing. So in this way, you can solve this one. So what is the A? A will be, this is the length. So this will be same thus in the previous question. So this is L over T square. A answer will be L over T square or L T raised to power minus 2. So B answer will be L over T cube. So L T raised to power minus 3. Because we want to cancel T cube with this one and our answer should be length. So this is the whole story of this chapter number 1. So if we will solve some more problems of this chapter 1 and then we will go forward on chapter number 2. Okay, if you have any question, you can ask me.
Doctor,
But
Yes,
is there any slides or something like that?
slides are available. So I will send you the slides. Okay.
Okay, thank you.
Dr. الحين we don't have to multiply the L2 minus square.
No, we will not multiply, but we just make it L. So here you can see, suppose this is BT cube. Okay. How to make it L? To make it L, we need L over T cube. What will be the answer of B? Answer of B will be this one. Understand?
Yeah,
Then-
so the unit of B is L over T cube.
Yes, not a unit. The dimension of B is
The
L over
dimension.
T cube. Yes.
Yeah.
The
okay.
dimension of B is LT minus 3, like this one. Okay. The dimension of A will be this one. Okay.
Excuse me, I have a question.
Yes.
The dimension of X is always L, right? Length.
Always, not always, but he will say in the question that X is measured in meter. So when it is
Okay.
measured in meter, its dimension is L.
Okay, thank you.
Yes. Yes, any other question? If you have any other question, you can ask. So if you don't have any question, and so see you in the next lecture with more things, okay? And inshallah, I will send you all these things and you can study yourself and discuss with me at any time. Okay,
Okay, thank you.
Thank you
Okay.
very much.
Thank you very
Okay.
much.
Thank you,
okay,
Dr.
thank you.
Doctor.
Thank you. Assalamu alaikum.
عليكم السلام ورحمة الله
Thank you, sir.
وبركاته.
Okay, thank you.